I want to review some of the built-in classes in Java, which are similar to C#. You might have already learned them in C#, but I want to review them, and then we will come back and learn some object-oriented concepts, okay? So I want to start out with the built-in math class. Then I will going to transition to the date class, okay? So let's create a new class here. We're going to call it Demo Math 1 with a public static void main. Since we do not have any operator in Java to calculate square, we have to use a built-in function POW from the math class. It's the same way in C# as well. So for example, double C equals to math dot POW a comma 2. So we calculate the square of a. We have not declared a. Let me declare a as well. A equals to 7.5. So the square of a becomes the value of c. Value of c is this. Similarly, I can include another variable called b and give it a different value, and then use it in my formula. So here I have c is equals to a squared plus b squared. Does this formula sound somewhat familiar? Not exactly the same, but very close to
it's for a
this
triangle.
guy, right? This guy?
Pythagorean theorem.
Exactly. So the only thing we are missing here is what? The square root, right? And of course, another concept could be that you have to put square root around it. We do not have any symbol for that, and we do it exactly the same way that we do it in C# by calling the square root function from the math class. So this would basically be equivalent to what you see right here. That c is equals to the square root of the a squared plus b squared. That's why you have to make sure the square root parentheses surrounds both squares and their sum, or the sum of both squares, rather. So as you can see in this example, that how you can make one function surround the other function. So the inner function will run first, and then the outer function will run. So in this case, a squared will be calculated, then b squared will be calculated, then they will be added together, then their sum will be square root. Now, since my answer is pretty long, I can use another math function to round my answer. Now I have three choices in the math class. I could round. In that case, I get a long data type value. It simply truncates the decimal altogether, but what it does, it either rounds up or round down based on the decimals. Now, in this case, it is 9.3, so certainly it'll going to round down to 9. Then we have a function called ceil, which returns a double value, but it always rounds up, so it's always going to give you 10. And then we have a floor, which always rounds down, irrespective of the value. So let's try a round, math.square root, math.round, okay? So make sure you put parentheses on both sides. And now run it again, and you will see the value is 9.0. Why 9.0? Well, round will return a long value. However, C is of type double, so that's why the answer is 9.0. If you would just leave it to math.round, then he will just give you 9 because math.round only returns integer values. If you change the word round with the word seal and rerun the example, you will get 10 because it always rounds up. Seal for sealing. And floor will always round down. So in this case, floor and round will give you the same output, and seal will give you a different output. Copy this whole thing, but not the data type, and paste it again. But this time, you will going to get rid of this math.seal part, but leave the parentheses around. Just get rid of math.seal. We have a Java built-in class called decimal format, which can set a decimal format to a certain number of decimal places. For example, if I want to go 2 decimal places, so I'll say my format is hashtag for numbers dot 2 zeros for 2 decimal places. And since it doesn't belongs to java.lang, therefore you have to import. So you can hover over and choose the import, or you can use the keyboard shortcut of Control-Shift-O. Or you can click the source menu and choose Organize Imports. Either of the 3 approaches will give you this import statement. Now, the only difference is that the format returns a string. It doesn't return a double value. So that's the only drawback to this whole process. So what you can do is this. One way to solve this problem would be to directly put this in a system.out.println statement. That way, you don't have to worry about any kind of implicit or explicit problems in terms of, conversion types. So as you can see, the output is now rounded to 2 decimal places, 9.30. Okay. So this is how you can be using the math class. Of course, there are other math functions as well, which I would use in my second example. So let's create another class called demo math2 with a public static void main. We have a math function called random. It allows you to generate a random number. Let's see what kind of a random number it generates. It generates a number between 0 and 1. And that's exactly what random number does. Every time you run it, it generates a number between 0 and 1. To make it generate a higher number, you can simply multiply this with, let's say, 100. And that will now help you generate a number in a higher range between 0 and 100. So you can simply multiply a number with a higher number. If you want to create a whole number, then you can always round it. So you can see that it rounds it. Sometimes it rounds up based on the decimal places, sometimes rounds down. What I will do next is I will create two random numbers. And let's see which one of the two is a maximum, is a greater random number. Okay. So we can also do this by calling, or rather, let me display both random numbers so that you can see what their values are, random 1 and random 2, and greater of the two random numbers. And then you can call math.max and then give the two random numbers, and it will automatically give you and now if you run it, every time you run it, it may give you whatever numbers of the two is greater. Similarly, you can also find the minimum of the two, lesser of the two numbers, random numbers. So this will clearly tell you that it shows the more and the less, both of them. Now let me introduce another random number. And let's display this random number as well. And now we will try to find maximum of three random numbers. The problem is greater of the three. The problem is that max can only take two parameters. It cannot take three parameters. So what we will do is we will replace the second parameter with another call to max. And that's how we can figure out the max of the 2 and 3. And whoever is the larger of 2 and 3 can be compared with 1. So of course, the larger of 2 and 3, if it is greater than 1 as well, will eventually win, right? So that's how you can chain these calls as well. So here you can see that the greater of the two random numbers is this, and somehow turns out to be that's also greater of all. But in this run, the one that I just ran, the greater of the two was 0.14, but the greater of the three was 0.66. Also, Java can do some trigonometry. So let's say if I have a variable called degrees set to a value of 45, I can convert it to radians by calling math.toRadians and giving it the degrees variable. And that can give you the relationship between degrees and radians. So 45 degrees is 0.78 radians. And when we use the sine and the cosine and the tangent and the arctangent and arc sine, arc cosine, those functions require the values to be in radians. So we can also do that in Java. So for example, I can say, I want the sine value to be calculated by calling math.sine, and I'm going to pass this radians as a parameter. So sine, and then I can just display this degrees, right, in parentheses, equals to sine value. So it'll tell you that sine of 45 is this. And the same principle you can call math.cosine cos, math.tan for a tangent. It's basically the same stuff. You can just change the function. The methodology stays exactly the same.